Reaction of metals with water. Alright, now how do metals react with water? A metal reacts with water to produce metal hydroxide along with the release of hydrogen gas. Let us have some examples. Let us consider the case of sodium and potassium first. Sodium, it reacts with water to produce sodium hydroxide, NaOH, with hydrogen gas. Similarly, potassium, it reacts with water to produce potassium hydroxide, KOH, along with the release of hydrogen gas. Now both sodium and potassium, they are very reactive metals. Very reactive metals. Now because these metals are very reactive, the reaction of these metals with water is very, very violent and a large amount of heat is released. When a large amount of heat is released, we say that the reaction is exothermic. Alright, exothermic reactions you have already covered in the first chapter, that exothermic reactions are those reactions in which heat is released. Alright, so sodium and potassium, they are very reactive metals. They readily react with water to produce metal hydroxide with hydrogen gas. Alright, so because they are reacting very readily with water, a large amount of heat is released, and we say that these reactions are exothermic in nature. These reactions are exothermic in nature. Now the heat released in both these reactions is enough for hydrogen to catch fire. Alright, such large amount of heat is released that the hydrogen gas which is produced, it immediately catches fire. You have already seen this reaction in the lab last year, the reaction of sodium metal with water, and you can see that you have seen that how large amount of heat is produced, and it is a highly exothermic reaction, and hydrogen immediately catches fire in that reaction. All right, you have already seen this reaction. Okay, so sodium and potassium, both of them, they are very, very reactive metals and react vigorously, violently with water. Now let us take the example of calcium. Calcium also reacts with water to produce calcium hydroxide and hydrogen gas. Although calcium is less reactive than sodium and potassium, it is less reactive than sodium and potassium, so the reaction is not so violent. The reaction is not so violent. Alright, and large amount of heat is not produced. The reaction is exothermic, heat is produced, but the amount of heat produced is not so large, it is not enough for hydrogen to catch fire. So in case of the reaction of calcium metal with water, the heat released does not let hydrogen catch fire. Alright, so hydrogen does not catch fire in case of the reaction of calcium with water. Alright, the reaction is not so violent as in case of sodium and potassium. Okay, now let us consider magnesium. I am not discussing the balancing in detail here because we have already discussed it a number of times. Alright, so magnesium also reacts with water to form magnesium hydroxide along with the release of hydrogen gas. Now magnesium is even less reactive than calcium. Magnesium is even less reactive than calcium. Alright, so when it is less reactive than calcium also, it does not react with water at room temperature. It does not react with cold water. All right. So whenever a reaction is not occurring at room temperature, what we do is we supply heat. All right. We increase the temperature of the reaction mixture for the reaction to take place. So magnesium, it does not react with cold water. It will not react with cold water to produce magnesium hydroxide and hydrogen. You have to supply some amount of heat for this reaction to take place. So we say that magnesium reacts with hot water. Hot water means when temperature has been increased, when the temperature of the mixture has been increased. So it produces magnesium hydroxide and hydrogen. All right. So magnesium, because of its less reactivity, it does not react with cold water, but it reacts with hot water to produce magnesium hydroxide and hydrogen. All right. When you heat the mixture, the reaction takes place, and with cold water, magnesium does not react. Okay. Now considering the case of aluminium and iron. Aluminium and iron. Okay. Now in case of aluminium and iron, these do not react even with hot water. Do not react even with hot water. Aluminium and iron, because of less reactivity, they neither react with cold water nor do they react with hot water. Instead, they react with steam. They react with steam. Steam. What do you mean by steam over here? When a large amount of heat has been provided to water. All right. When the temperature has been increased to a larger extent. All right. Okay. So let us write the reaction of aluminium and iron with water. Aluminium reacts with water to give. Now because of less reactivity, it does not form aluminium hydroxide. It rather forms aluminium oxide along with the release of hydrogen gas. All right. Because of less reactivity, aluminium reacts with steam. It reacts with steam, but to produce aluminium oxide and not aluminium hydroxide. Similarly, iron also reacts with steam to produce iron oxide, Fe3O4, and hydrogen gas. Let me quickly balance this equation. All right. Okay, so these equations are balanced now. All right, so what we have seen is, let us start from the beginning. Sodium and potassium, they are very reactive metals, so they readily react with water to produce their oxides along with the release of hydrogen gas, and the heat released is so large it is enough for hydrogen to catch fire. Calcium is less reactive than sodium and potassium, so the reaction of calcium with water is not so violent. All right, and hence the heat released is not enough for hydrogen to catch fire in case of this reaction of calcium with water. Magnesium, it is less reactive than calcium also. All right, so it does not react with cold water. It rather reacts with hot water to produce magnesium hydroxide and hydrogen. All right, so you need to increase the temperature of the reaction mixture for this reaction to take place. Aluminium and iron, because of less reactivity, they neither react with cold water nor with hot water. They rather react with steam to produce their oxides and not hydroxides. All right. Okay. All right. Now, metals like lead, copper, silver and gold, they do not react with water at all. Do not react. They neither react with cold water, nor with hot water, nor with steam, because of very less reactivity. Very less reactivity. All right, so they do not react with water at all. In fact, we even use copper, silver and gold in our daily life. We use ornaments made up of silver and gold, and while we wash hands, silver and gold, they do not react with water at all. Similarly, copper also, we use utensils also made up of copper, and some artificial jewelry is also made up of copper. So it does not react with water at all because of very less reactivity. These metals, they do not react with water at all, even at high temperature. We can understand this reaction of metals with water by taking help of an activity. Now in this activity, what I have taken is a test tube which consists of a piece of glass wool which is soaked in water, and along with that I take a metal. Now when this piece of glass wool is heated, water immediately moves this side and reacts with this piece of metal. Water from the glass wool, on heating, it immediately moves towards the metal and reacts with it. Now when it reacts with the metal, we know hydrogen gas is released. All right, this hydrogen gas is passed through the delivery tube to the soap solution, where bubbles of hydrogen are formed. Now you know how you test for the presence of hydrogen gas. If you bring a burning matchstick or a candle near these bubbles, they are going to burn with a pop sound, which proves that these are bubbles of hydrogen. So this is how you can prove this release of hydrogen gas using this activity in reacting the metal with water.